Hey, everybody. It's March 2nd, 2022. We are back with Introduction to Stats at College of the Sequoias, COS. And we were last time looking at normal probability distributions. It's in chapter 7 of the book that we're in. And let's just give you a quick recap. Let's do draw. So normal probability distributions make a bell curve where the mean is in the center, and we go out deviations in either direction. 2 that way. It kind of makes like the empirical model. Well, it does make the empirical model. And I probably don't have the curve very well, but it is bell-shaped like that. When we're doing it in StatCrunch, as a reminder, we will use stats, calculators, and normal. And the last time we looked at the standard, or we looked at the IQ scores. So the IQ test, the mean is 100, standard deviation is 50. And so often they'll want you to use, the homework will split between this. Generally, when they're going along the normal distribution or the standard deviation marks that appear at the 68, 95, and 99.7%, calculator's normal. And we do say I have to change it. When you have something besides 0 and 1, it pops up another option, the 68, 95, 99.7 tick marks that match the empirical distribution, or the empirical rule model that we use. So they'll usually want you to use that if it actually goes along normal, along those hashtag marks, the answers. And if it doesn't, then you need to actually use the calculator. And the reason why I say this is because if we look at like between, we discussed for a, let me just move this a little bit to the right, give it a little bit more. Let's put our 3 deviation marks there, our negative 3 deviations. Recall that we said between the middle 2 was 68% or 34% each. And then the next 2 were 95%. And between plus or minus, my markings are wrong. I got -1 twice. Two, 3. There we go. And then between 3 standard deviations is 99.7. That is the empirical rule. What are the actual values? Let's check. So when we put it into the normal calculator, standard deviation is 15. Now, if I go between 85 and 115, that should be within 1 deviation of each. And notice it says 68268. So plus or minus 1 deviation, it says 0.68268,949. And if we shift that to percentages, it's 68.27%. Not exactly 68%, but it's approximately 68%. And that's why we use 68%. It's easy to remember, a lot easier to remember than 68.27. If we go out another distribution mark, 70 and 130, it's bigger, 0.95449974, which is about 95.45%. Again, not 95, but we're still close. So we tend to use for 1 and 2 deviations, we tend to stick with those just because they're easy to remember and it's close enough for what we want to do. Where things get a little hairy and when you start getting into the real, is this an outlier range, is beyond 2 deviations. So if we look at 3 deviations, which we can see goes from 55 to 145, according to the graph that they give us in StackRange. Is it 99.7%? It's actually pretty close. Plus or minus, it's probably closer than any of the other ones. 0.9973002 is 99.73%. And here they don't want to just go 99%, like we did the other two that didn't have any decimal places. Here they actually just say they go with 1 decimal place because 99.7 is a lot higher than 99 when the cap is 100. Okay. So those are what they're doing there. Where's my mouse? There it is. And let's look at another example problem. So the weight of giraffes is normally distributed. I'm going to try to change my setup a little bit. Let's move my mouse over here. Move this over here. The weight of giraffes is normally distributed with a mean of 2,200 pounds. And a standard deviation of 200 pounds. That's information. Step 1 is to draw this distribution with a labeled graph. And so, and maybe I should be more specific with the 68, 95, 99.7 tick marks. We're going to do this by hand first, just to remind you that this is not that hard to do by hand. We need to set the mean in the center. So what are our tick marks? So if I've got mu is 2,200, and if I add 200, one deviation is 200 more, 2 deviations is 400 more or less, and 3 deviations is 3 times 200 is 600 more or less. So I'm going to deduct those from underneath it when I do my little hashtag marks. I'll put 1 in the center. This is my mean, and then I got to go out 3 in either direction. The 2200 goes in the middle. And I will add 200, 400, 600 going to the right. The easiest way to do it is just keep adding 200 to the number to the right of it or the left of it. And going the other way, I'll subtract 200. 2200 minus 200 is 2000. 2000 minus 200 is 1800. And 1800 minus 200 is 1600. So this will be our giraffe normal distribution. And then what we want to do is the next question will be shade the area to the right of 2500. And tell us what this means. Not tell us, and state what this means. So they'll ask you problems like this in the homework. 2500 isn't on my graph. Let's pencil it in though. 2500 should be exactly halfway between 2400 and 2600. That's my 2500. And so if I want to shade to the right of it, I would do this. And what exactly does this mean? So this is exactly halfway between the first and second mark. This is 1 deviation. This is 2 deviations. So this looks like this is like 1.5 plus 1.5 deviations. So we could say how do I want to put this? The best way to put this. Giraffes that are 2,500 pounds or more, that's the area that's shaded, are more than 1.5 standard deviations larger than the mean. What's another way to put this? Let's put this in StatCrunch. And we want greater than 2,500. And now I can actually give it a percentage. Look at that. Now I could also write this as, like when we get it from StatCrunch, that is 0.0668072 or 6.68%. So another way of writing that is only 6.6%. Let's go with 6.7% of giraffes weigh more than 2,500 pounds. That's probably more useful to the average person. Hell, that's more useful to a math person. That makes sense. If you tell me the standard deviations, I have to stop and think about it. And I teach this stuff. So this is probably the better way of saying it. Now, if it had been directly on one of the hashtag marks, like 2400 or 2600, I would have used the empirical rule to figure out that percentage. What if it said between what percentage of giraffes weigh between the first set we'll do is 2,000 and 2,400 pounds. And then we'll also, for D, we'll ask the same question, but we'll make it like 1950 and 2450. So the 2020, we can go to look at this right here. And it's going to show me this, the highlighted area is exactly on the hash marks, the tick marks, which means the best answer here is, well, the exact answer is the 0.68269 or 68.27%. Chances are homework may want just 68%, like the empirical rule. There's a good chance of it. Okay. For part D, 1950 to 2450, we don't have those values on our empirical rule. You can see what the empirical rule numbers are below this. We don't have those numbers there, so we're going to have to go with the exact value that StatCrunch spits out. And we get 78870045 or 78.87%. Any questions on that? Okay. Let's see, where's my mouse? Nothing going on in chat, so I'll assume no. So, like, if we had information on elephants and we wanted to like compare a weight for an elephant to the weight of a giraffe, but we're trying to see like how big they are relative to their group, it's a little hard to do with this. So another way we compare can do this type of distribution. Is turning it into z-scores. I think we talked about z-scores before, but it's been a while. So each of these values, each x value that we normally have is the mean plus some amount of deviations away, and we call those deviations z deviations away. I want to get rid of that squiggly because it looks like x bar. So each x value is the mean plus or minus. Nope, I'm just going to go with plus. Because if z is negative, that's how we get the minus. Plus z deviations from it. That looks crappy. So if I wanted z-score, we can do it. This is very similar to what we're going to do in chapter 4. If I wanted to get z by itself, I can do some algebra here. I can subtract the mean from both sides. And I get x minus mean equals z times sigma. And if I want to get sigma by itself, I divide both sides by sigma. And if I do that, I'm just left with z on the right. And on the left, I have x minus mu over sigma. This is how we convert to z-scores. I think I've given that to you before, but I had z on the left. If I write that the other way, z on the left, z equals x minus mu over sigma. I put that little bar on my z to make sure it doesn't look like a 2. That's why my z's look like that, because that can look like a 2. So let's convert our giraffe scores. We were looking at 2,500 pounds. And then we looked at, let me go, I can grab it. 2,000 to 2,400 and 1,950 to 2,450. And we'll do each of those as a z-score thing. So 2,500. Switching it to z, I get z equals, the 2,500 is my actual x. And recall for the giraffes, the mean was 2,200 and the standard deviation was 200. So I'm just going to put those values in. And you do the operation on top first. 2,500 minus 2,200 is 300 over 200. And then we can divide, that's 3 over 2 or 1.5. And it's positive. So 2,500 is 1.5 deviations larger than the mean. That's what that z-score is telling me. So when you see z-scores, that's what it means. Z-scores represent distance from the mean. Z-score represents deviations from the mean. And let's take a look at it when we do here, 2,500. We did greater than 2,500. And we had that 0.668. When we switch to z-score, in z-score world, the mean is 0. Oops, that looks like standard deviation. And that I did write it as standard deviation. The mean equals 0, standard deviation equals 1. So let's just like eyeball, try to remember where that red is right there. I'm going to switch to a mean of 0 and a standard deviation of 1. And I computed it as 1.5. So that's what I'm going to put here. X is greater than 1.5. And notice that it looks the same. So in Z-score world, mean is 0, standard deviation is 1. And I will reiterate that again in a second. Let's look at our other values. We had 2,000 and we had 2,400. In fact, I'm going to just set them all up right now. 1950, 2450. In each of these, we say the X value is on top, X minus mu over sigma, minus that 2,200 over 200. So I'm going to do that in all of them real quick. And notice the only thing that's changing is that first value on the top. A little line in between. 2,000 minus 2,200 is negative 200. And that's going to simplify to negative 1. And this is going to be positive 200. 2,400 minus 200 is positive 200. So this will be positive 1. And we see when we put this in Stack Crunch, that graph looks like what it did when we had that up there. And now I do the next one. We got 1950 minus 2,200 is negative 250 over 200, which is negative 1.25. And this is the exact same thing the other way, going the positive amount. Positive 1.25. And I'll just add those values in and we'll see that we get the same thing that we had before. Oops, I must have a comma. I do. That 0.7887, ooh, something in chat. We saw the 0.7887 up here. I wrote 97, look at that, bad. All right, let me see what we got going on in chat right there. I can go back up a bit. Giselle, tell me how far back up you want me to go. If I'm not responding to your request, open up mic for a second. Just say, hey, Mr. Jones, or something in chat, or tell me what you're asking. Because I don't want to lose you guys in the discussion.
She said she got it.
Yeah, I know. I just mean for the future. For the future. I don't know how long that's been sitting in chat. I've got my tablet next to my keyboard. I'm looking at my tablet a lot. I'm not looking at the chat screen. All right, so that actually kind of takes us into 7.2. 7.2 is the standard normal deviation. Or standard, not deviation, distribution. And where in 7.1, the mean equaled whatever it did, and standard deviation equaled whatever it did, in 7.2, the mean equals 0, and the standard deviation equals 1. So the standard normal distribution is in Z-score world. World sounds funny. Let's call it Z-score land. I'm making up my terminology as I go. And you'll notice when you start the calculator up, stats, calculators, normal, and StatCrunch, it defaults to the mean equaling 0 and standard deviation equaling 1. So StatCrunch defaults to these values. When you use the normal calculator and you're not in Z-score land, you need to either change the mean and standard deviation in the calculator on the screen, or you switch to Z-scores. And I think it's easier to just change the mean and standard deviation on the screen, unless it's very specifically asking you. Do it in Z-score kind of thing. So you'll see a couple kind of terminology notations in this chapter. And I wanted to let you know, if you see something like Z-score, so let's say notations. If you see Z-score and then like a number, for example, Z 1.2, example, what this means is find the probability, or not find, it's equal to the value of the probability that Z is less than 1.2. So if you see this thing underneath it and it's just a number, they just give you a number, it means to calculate the region to the left of it. And we're going to the left. So that's pretty easy. We can do this in the calculator. I'll put in 1.2. So Z with a subscript of 1.2 is 0.88493. Another way of saying it is, what is the area to the left? Let's see what the area to the right would be. So the area to the right of Z equals 1.2 is 0.11506967. Which, if you take this score and plug it into your calculator and do 1 minus Z of 1.2, you're going to get that. 1 minus 0.88493 and I had more decimals written or on the screen for that one. I didn't put them. Equals 0.11507. Which is the same thing, I just with rounding. So when they want to show this, when they want the area to the right, they usually will say Z and then alpha, where alpha equals 1.2. That is alpha. Oh, I don't know if I ever told you guys this. This is fun fact. Here's your Trivial Pursuit question, Jeopardy question of the day. Where does alphabet come from? Why do we call it alphabet? The first 2 Greek letters are alpha and beta. And I'm going to put a little hyphenation in here because it's pronounced beta. A lot of people say, most say beta. But they're wrong. It's beta. I know because I went to grad school with someone that was Greek, and the teacher kept making fun of us when we screwed up the like English accents, stuff like that. And then she started busting him on beta because he said beta, and she busted our teacher's chops on it. It was great. And beta sounds like it makes sense. Alpha, beta, alphabet, alphabet. There's your fun trivia question. So back to the stats. Z alpha, they'll say Z alpha, when they're saying Z alpha, they want the area to the right, which means like if, and sometimes they'll say like Z alpha and alpha equals negative 2.3. They might say Z alpha equals negative 2.3, like that. In both areas, they're wanting us to get the probability that Z is greater than negative 2.3. So let's just figure out what that is. Is anyone not at their computer or where they would do Stack Crunch? Because I want to give you guys like 6 or 7 of these to just try out, get familiar with it. You'll see them on your midterm. You'll need to know how to do this up front, several questions on your midterm. So I thought I'd give you some practice when I'm with you guys live. If you can open up My Math Lab, open up Stack Crunch, and get your standard or your normal calculator open. Let me give you guys some ones to practice on. And I'm not going to do the alphabet or the Z alpha. Well, I'll just write what there actually are. Let's go with probability. Let's see, A, B, C, D. I'll give you 6. 7. Probability that Z is greater than negative 1.3. Probability that Z is less than 0.74. Probability that Z is greater than 0. Let's do probability that Z is between negative 1.2 and negative 1.5. Probability that Z is between negative 0.67 and let's go with 1.56. I'm just making these up. I'll calculate them with you. I'll just do 6. Negative 2 is less than Z, which is less than positive 2. Take a few moments to work those out. Make sure you know how to get them. We'll go over the answers on this live so you can make sure you know what you're doing. Give me a couple minutes for that. If you have any questions, let me know. Okay, the first couple are in the standard. Anyone still working on this? Did anyone do this? Or did y'all just take a 4-minute break?
I'm doing it.
You're doing it?
Yeah.
Okay, I'll give you another minute. I can wait. You're still doing it. I would like to give you the practice. Okay, let's start going through. We got z is greater than negative 1.3. I'm getting, ooh, I'm on eraser, that's why. 0.90319952. Z is less than. Notice it says X here. There's no way to change that to make it look like Z. So you're just going to have to accept that when it's the mean is 0 and standard deviation is 1, this really means Z. But otherwise, everything works just the same. Z is less than 0.74. If you want to see the neat symmetry in it, if I make this negative and change the sign, I'm going to get the same value. 0.77035. That's what we mean by the symmetry of Z, or the normal distribution. If we switch sides and change the value, it's just equal to the other one. Next one was Z greater than 0. I don't need a calculator for this. I know the rules say that the area equals 1 and 0 is the dead middle. This should be 0.5. But I'll put it in there just to show you. That was me setting up one that I knew the answer to. Hopefully, if you didn't know the answer to it, you'll remember that now. Then we switch to between. And we've got 1.2, negative 1.2, and negative 1.25, or negative 1.5. I didn't make it a very big range, did I?
Yeah, this one doesn't work. You have to.
Oh shit, I have them backwards.
Yeah.
Fail. Fail. Epic fail. Fail, 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 fail. I know that. This is what happens when you pick numbers like this for the moment. That's a dirty trick. No one said anything about it either.
I did.
Well, you did right now. Look at how thin that little sliver is. That was a fail on my part. I'm embarrassed. Don't go telling other math teachers. We like to heckle each other, I'll have you know. Me and Professor Redden, John Redden, we do it all the time with each other. We both teach computer science. He doesn't do stats though, so. And negative 2 to 2, we actually did this earlier. When we did the IQ one. And so if they actually give you z-scores like this, and they say between negative 2 and 2, they'll probably want this answer. There's no telling. They might go, this is also the empirical rule. Empirical rule would just say 95%. So keep that in mind. A good rule of thumb in the real world, if the z-score is an integer, which is a fancy way of saying a whole number, positive or negative whole number, then use the empirical rule. Otherwise, calculate it. And use the empirical rule for the probability, I should say. Otherwise, calculate it. So pause for a second, make sure you get to write that down. Let's look at some examples. You are a gizmo manufacturer. And you know that defective items deviate a lot from the mean. And so you decide to scrap, let's say the top 10%. I need to make that look like 10%. And bottom 10% of the gizmos. What z-scores are the cutoffs? That's our question. So to do that, I can come over to there's a couple ways to do this. I can come over to the standard calculator. And when we're entering stuff in StatCrunch, what do we, let me just draw a window of what we have. We have mean, there's a box that says 0. We have standard deviation, and a box that says 1. And I got probability, that X, and then a box for the symbol, and a box for the value, and then a box for the answer. So I'll put value there, and answer for area / probability is over here. So it says top 10%. We're not given the value. What we're given here is that probability. So let's take that 10%, convert it to a decimal. And I'm going to type it in the right-hand box. Let's put that in the right-hand box, 0.10. And I look at it and I go, is that the top numbers? Yes. It's very important to make sure I'm looking at the right stuff. If it was shaded the other direction, my symbol is wrong, but it's not. It's shaded so that I see the top. And so now the answer that I'm looking for here is actually, this is what we want. So I'm getting Z equals 1.28. That's a shitty 8. 15516. And if I want to do the bottom 10%, all I got to do is change the symbol. But because of symmetry, I should get the same thing. Oops. Why are you not? Negative 0.10. And I click compute. Oh, my bad. I don't mean negative 1.0, less than. Just the 0.1%. My bad. I know probability. I'm just dropping the ball. I just said probability was negative right there. I'm having an off day. If we click compute, notice it says the same thing for the bottom 10%. Gives me a z-score of just the opposite sign. That's one way to do this. Another way, if I'm looking at the outer 10%, I'm really looking at this lower 10% here, this upper 10% here. If I do between and go with the value that's like the probability of what's in here, I can figure it out. If this is 0.1 and this is 0.1, this area right here has got to be 1 minus 0.1 minus 0.1, which is 0.8. So I can switch to between. And I don't think on the between you get to choose the symbol. Those are locked in. But they'll put a box there, and then we have our box over here. I'm going to put that 0.8 right there. So I'll switch to between, and I'll change this to say 0.8. And now it gives me the same z-scores, but it does round. It doesn't have room for all of it. It will round it to say negative 1.2816 less than or equal to z, less than or equal to 1.2816. Okay. Next example. The GRE scores. And when I say GRE, I'm talking about graduate research examination. I think it's research examination. I can just look real quick, right? Graduate test. Graduate record examinations, my bad. You take a test, and everyone that takes the test, they have testing dates and times. Everyone that takes the test in the country takes it at the same time, gets the exact same version of the test. And then the only people they compare you to are other people that took the exact same test. Because if you change problems and, change the test, it becomes, it's harder. It's harder to compare one group to the next. So that's how they tend to do it. And then they give the results in percentiles. Okay, so let's say you got the 88th percentile. What is your Z-score? I'm going to have to look up what I got. It was fucking terrible. I took the GRE for mathematics, and for the mathematics exam, they test you on all areas of mathematics, both theoretical or the pure mathematics or applied mathematics. And all of my undergraduate classes were in applied mathematics. But most people that go into mathematics go pure. So I think there was more pure exam questions than theoretical exam questions. And just some of it, I had no idea. I don't know, set theory. I've never done abstract algebra. Never taken some of the classes that are just standard classes for a math major. I got slaughtered. Like I want to say it was like 40% or some shit like that. 40th percentile. Recall, we've talked about percentile before. Percentile is the percentage of people that scored lower than you. Which means if I was 40th percentile, that means 40% of the people did worse than me, and it meant 60% of the people did better than me. And I blame it on the pure math, applied math. It might have just been that I suck. I don't think I suck. I do pretty good at this stuff. I'm better than most students that I work with. And I'm including when I was a student. I'm not talking about now. Of course, I'm better as a teacher than the students that I'm teaching. But that just comes from practice. So what this means is what we're looking for is I am looking for the probability that Z is less than or equal to some value, and it's going to be 0.88. So I'm going to come back over here and put 88. And Z percentile is always less than. It's always less than. So the Z-score here would be 1.1749868. One more example in this section. But let's give you a couple like rules of thumb to go with. If they want, a lot of times they'll want Z-score information, but if a problem doesn't come with Z-score values, or normally distributed, we're going to make it that way. We're going to make it that way by converting to z-scores. And then B, make sure you put in the right mean and standard deviation in the calculator. As you're going through them, they'll have you switch back and forth between z-score and regular, like normal deviation. So it's always worth it if you get the answer wrong, make sure you got the right mean and standard deviation right here, okay? Let's do one more example that covers this now that I went over like the general rule of thumb, and we'll use that advice in this example. A steel rod company produces steel rods, of course. With a mean length let's say 100 centimeters and a standard deviation of 0.45 centimeters. Question A is find the proportion of rods that are shorter than 99.2 centimeters. Then for B, we're going to say between 99.7 and 100.4. And then C, what are the middle 90% z-scores? No, that's not a question. That's a statement. Find. Okay, so when we're going to go through this, in the first question, the proportion of rods that are shorter than 99.2. Well, they gave us the mean and standard deviation. I'm going to use that. Might as well use it. That way I don't have to do z-scores. Standard deviation was 0.45. And then I want shorter than 99.2, which means X is less than 99.2. And it just gives me a nice little value. And then we have between 99.7 and 100.4. Again, why go to z-scores if we don't have to? Let's just switch to the between tab and do those values. Oops. And StatCrunch gives us 0.56047606. I always write down all the numbers, and then when it asks me how much I want to round, that's when I check the rounding. You always want to use all the numbers when they give it to you until you're at a final answer. And then it says, what are the middle 90% z-scores? So we've got two ways that we can do number C. Option A, find the values and convert to z-scores. And we'll do that first. So I want the middle 90%. I'm going to leave the mean and standard deviation alone. I don't know what those values are, but I'm going to change this to say 0.90 on the right. And that should give me the values for the 90%. Now I know that this is symmetrical. So if this is A over here, Z equals A over here, this is going to be Z equals negative A over here. I really only need to do one of them. For when it's like middle like that. If they gave a range, we'd want to do something different, but here it's just the middle. So I know it should be symmetrical. I'm gonna go with the greater number here and use that. And remember, Z equals X plus mu over sigma. Mu was 100. Sigma was 0.45. So when we do this here, I've got 100.7402 minus 100 over 0.45, which equals 0.7402 over 0.45. And I can't do that in my head. So we will do a calculator. And I'm getting Z equals 1.644 and then an 8 that just keeps on repeating. Repeating 8s, they put a bar over. Whatever number gets repeated, they put a bar over. And since this was symmetrical, I'm going to say Z equals plus or minus that value. Option B, convert to Z-score first. So I think both pieces of information are kind of helpful. The middle 90%, but the person might want to also know that it's between 99.2598 and 100.7402. I think my boss at the steel rod factory is going to want to know both pieces of information. Here I can convert to Z-score first, find the Z-score value, and then figure out what X is from there. Then find my X's. So if I go to z-score first, I got to make this 0 and I got to make this 1. And then I'm just going to say middle 90% is 0.9 right here and find out what z-scores are. And I get my z-score is, and lo and behold, look at that. We get the same thing we got above. And then if I want to find my x values, we had z equals x minus mu over sigma. And this is the same thing as x equals mu plus z sigma. So the left value, let's call it x1, is going to be the mu minus it, mu minus z sigma. 100 minus 1.6449 times my sigma, or my standard deviation was 0.45. X2 will be the plus version. So what do we get? I'm going to do and I get, for the first one, when I throw that all in the calculator, 100.740205. And the other one, I get 99.259795. And you can see, with other than a little bit of rounding, oops, this score looks like that. And that score looks like that. So there's a couple ways to do that. Any questions?
Do you have them backwards?
What?
Do you have them backwards?
I do have them backwards. Look at that. I totally have them backwards. Thank you.
I was looking at it and I was a little confused. I was like, how'd you get those for those?
Yeah, I wasn't paying attention to what I wrote. I was just doing the operations. I wrote them in the wrong spots. That good eye. There we go. So here's another type of problem you'll see. It's from the homework. So the gestation periods of Yumian pregnancy. How long does it take that baby to become ripe and say, let me out? From the data we have, the mean is 266 days. And the standard deviation is 16 days. So these are both days. Question A will be, find the percentage of babies that take longer than 270 days. 270 days is approximately 9 months. That looks like 9 mouths. It should say 9 months. So we'll do that one first. We've got a mean and standard deviation. We're going to put it in there. And it says longer than. I don't need a between. So I'm going to say X is greater than 270. Like they just give us the numbers and we just got to know where to put them. It says a good percentage. Now, if the computer asks you percentage and they're going to want, this is not a percentage as it's listed. Remember the percentage, we got to shift the decimal point. There'll be tricky bitches like that. Like they might give you the box and then put the percent symbol right after it with a question mark. And you're like not even looking at it and you go type in the decimal and you'll be like, it's wrong. And you'll think, what am I doing wrong? I don't know what I'm doing. So many students taking stats, that's their first thought is, I clearly don't know what I'm doing. And no, you probably had the right answer, but you missed that they were asking for a percent. So make sure you read the question. Oh. So that was that question. What's the next question we're going to go with? So very preterm babies are born in less than 224 days. Which is about 7.5 months. So what percentage here? So we want less than. And we're going to go with 224. And it said we get 0.00433,245. Or 0.433245%. They'll probably ask you, is this unusual? This is unusual. The value is less than 0.05. The percentage is less than 5%. And then they might ask something like, what gestation period captures the inner 90% of babies? We'll say rounded to the day. We don't want partial days. So if it wants between, say 0.90 here. And this gives me 239.6823 to 292. 0.3177. I done wrote this shit all wrong over here. My mouth was saying one thing, my pen was doing something else. And they want rounded to the nearest day. Now, if we go with normal rounding things, like these are my values right there. How do we actually round this? Normally, if we round according to rounding rules, this would round down to 292 because the 3 is less than 5. Here, 6 is greater than 5, so we would round up. This would go up to 240, which would be right there. Does that capture 10%? No. This is only 0.8958. If we wanted the inner I'm sorry, not 10%, 90%. This isn't 90%. So you got to kind of read the question and you're going to round so that it captures the data you're looking for. This is the data that we're looking for. We need to pick values that we round to such that when we put them in, we capture that entire range. And the only way to do that is to go outwards. We'll go 239 and we'll go 293. This should capture more than 90% because this part here is the pink is 90%. So this should be a little higher than 90%, but that's okay. At least we've met the description. The inner ones don't actually meet it. And notice that gives us 0.908. It does capture it. And it captures all those numbers. So these are the answers that we would use. 239 to 293. You'll see problems similar to this. Problems similar to this. Might say top 10%. Hell, the GRE, even the GRE one we did. They probably wanted us to round there, and I didn't do it. I don't know if they have decimal values for GRE scores, though. But here they said rounded day. When it says top 10%, I didn't need to make it that long. You'll get a value that is generally not an integer. So this is your actual value. And you're deciding above or below. If you want the top 10%, you got to go the lower number to capture the bigger region. So it kind of helps to sketch a picture and go, what area would get it? If I chose the other direction, that's not what I want to undo. If I went with the other direction, I'm missing this section right here. So that's bad. I want the one that I got to go with the one on the left. The one on the left will get that one and this side, and we'll have the right answers. Just keep that in mind. That's it for what's on the exam. That ends the content for the midterm. Okay. I can spend 15 minutes starting chapter 4, or we can call it a wrap. What do you guys think?
I think we can call it a wrap.
I didn't hear what you said. There's a lot of feedback.
I said I think we can call it a wrap.
Call it a wrap?
We were saying a new chapter, right? Oh, chapter.
Yeah, this is the end. There is another section in chapter 7. It's 7.3, but we kind of need chapter 4 for it, and it won't be on the midterm. So this ends the content for the midterm.
Okay.
All right, we'll call it done there then.
All right.
Have a
See
good
you
day.
later.
Thank you, Mr. Jones.
Thank you. Glad to see you guys again.